Welcome back, everyone. Next up, we have ASP Isotopes, Inc. It trades on the NASDAQ under the symbol ASPI and is an advanced materials company dedicated to the development of technology and processes designed to produce isotopes used in multiple industries. They have an exclusive license to use proprietary technology, the aerodynamic separation process, ASP technology, for the production, distribution, marketing, and sale of all isotopes. Please welcome its CEO and chairman, Paul Mann. Welcome, Paul. How are you doing today?
Great. Thank you for having me. It's great to be here. My first time at this conference, but thank you.
Good. Well, welcome and take it away. Call me back when you're ready for questions.
Great. Thanks so much. So I'm starting on slide 1. Hopefully you can see the slides. Some forward-looking statements here that I'd like you all to review quickly. So, just a quick summary of what we do. We have some technology that allows us to enrich isotopes, particularly low mass isotopes. And our technology is useful because it's very low capital cost. Typically, isotope enrichment plants are really large, multi-billion-dollar equipments that are typically run by government entities. Our plants are very small in footprint. They're modular in design. It allows for expansion and shrinkage of capacity as demand kind of grows. And our process is very environmentally friendly as well. There's very little waste from our process too. So we've got a green company. Our first isotope enrichment facility commenced operations just a couple of weeks ago. That should start generating revenues in the second half of this year. And our second isotope enrichment facility is expected to be mechanically complete during the second half of this year, with revenues expected shortly thereafter. And we've got a huge backlog of demand for additional plants from both companies and governments. Historically, Russia has been the largest supplier of isotopes, and clearly there's a lot of interest in whether we can supply what used to come from Russia. So first of all, what are isotopes? Well, basically, an isotope is a chemical where the number of neutrons inside the nucleus are different. So they have identical chemical properties, but different physical properties. It's very hard to separate them using chemical processes. So as you can see, it's this picture of M&Ms. Here we separate the orange, the green, and the blues just using our sight. For isotopes, we enrich them by spinning them very fast in a tube and separating them by mass. And let's take a really simple isotope, for example, silicon. So sand on the beach. If you take a kilogram of sand, that probably costs you less than $1 a kilo. But when we enrich the silicon-28 to very high levels for quantum computing, that same kilo of sand is likely to be worth about $600,000 a kilo. So we're taking something that is, less than $1 a kilo to $600,000 a kilo. And when you think about carbon, take a kilo of carbon, so charcoal, something like that, standard kind of carbon. That again sells for less than $1 a kilo. When we enrich it to carbon-14, that same kilo sells for about $24 million US. So we produce very valuable, very special chemicals that are used in particularly very specialist applications in everyday life. What are some of these applications? Well, lots of isotopes are used in medical diagnostic imaging and treatment of various diseases. Obviously, nuclear energy, food irradiation, and so forth. And when you think about a lot of the megatrends emerging right now for the future of the world, certain isotopes are going to be required to enable them. So quantum computing, for example, is going to require lots of silicon-28 to allow processors to process at the speed you need to process for quantum computing. And there are many new advanced medical therapies and diagnostics that are coming to the market over the next sort of several years that are going to require very special isotopes. And obviously, new fuels and energy for the world to meet climate goals will also come from isotopes. So why are isotopes interesting right now? I guess it's both interesting from the supply and the demand side at the moment. So when we look at the supply of isotopes, let's take one of the most common medical isotopes used, molybdenum-99. That's produced in 10 nuclear reactors around the world. And 9 of those 10 reactors are expected to shut down over the next 10 years. They've reached the life of the end of their useful life. Also, Russia has historically been the most significant supplier of isotopes to the market. And, given the current geopolitical situation going around the world, many companies and governments are reassessing who their suppliers of isotopes are. So that creates a pretty interesting supply side picture right now. In terms of the demand side, there's a lot of new isotopes coming to the market over the next several years that aren't really produced in mass quantities or produced by Western producers today. Historically, the demand for medical isotopes has been at kind of the 4 to 5% rate per year. That's just typical GDP kind of healthcare type growth rate. But in the coming years, we expect to see very large market opportunities for things like molybdenum 100 and molybdenum 98, zinc 68, which will be used for the production of gallium 68 and copper 67. Ytterbium 176 is emerging as a better way of producing lutetium 177, which is an emerging cancer treatment. Nickel 64 is becoming an important element used in radioimmunotherapy. And then carbon 14, we've signed an MOU for the entire world supply of carbon 14, which should come on later on this year, and that used to be supplied by Russia. And when you think about quantum computing, that's going to require lots of silicon 28. And there's no Western producer really of any of these isotopes in kilogram quantities at the kind of level of purity you kind of need to get to enable a lot of these technologies. And then when you look at energy demand in the future and green energy, there's no Western producer of a new type of uranium fuel called HALEU or lithium-6, which will be required for nuclear fusion reactors, and chlorine-37, which is going to be required for molten salt reactors. And so there's a lot of emerging opportunities as well. So you're seeing a pretty healthy secular growth in demand, and you're also seeing a pretty kind of shrinkage of supply or a curtailment of supply at the same time. This slide here kind of shows the isotopes that are of interest to us right now. We'd expect to have commercial quantities of the top 4 available during 2023. And then we've got a long list of isotopes that are currently in research and development, and we have a long backlog of interest from customers who are interested in these isotopes. So here's a picture of our first plant. It will produce carbon 14 in the second half of the year. We expect to produce carbon 14 in the second half of the year. But these kind of 5 cages essentially contain the separators that we use. And these are sort of 2.5 meters high by 2 meters long and a meter wide. And there's an urgent need for carbon 14. Russia has historically been the sole supplier of carbon 14, and there's historically been significant supply side shortages. And right now, there's no carbon 14 available. You can try and buy it, and there's just nothing there. So we've signed an MOU to supply carbon 14 to a North American customer. We expect to start supplying that during the second half of the year, probably sort of fourth quarter. And our plant can produce the entire world's demand of carbon 14, and this should generate substantial amounts of free cash flow for the company, starting towards the back end of the second half of the year. I mentioned molybdenum 100 and molybdenum 98 already as well. These are large opportunities for us. The molybdenum 99 market's about $3.5 billion, and the 10 nuclear reactors that currently produce that product, 9 of those are supposed to shut down or expected to shut down in the next 10 years. Moly 100, you can convert that into either Moly 99 or technetium 99 at the point of care. So Moly 100 is a stable isotope. So rather than shipping an isotope that's decaying and reducing in value every day around the world, you can just ship our product in a standard normal shipping package, keep it on the shelf as inventory, and use it as and when you need it. We've signed a 25-year supply agreement with a Chinese customer called Brichem for the supply of highly enriched molybdenum 100, and that's up to about $27 million a year. That contract is, and we expect to start supplying that during 2023. And the final isotope that is of interest to us in the short term is silicon 28. We've actually enriched silicon 28 in the plant you saw a moment ago for carbon 14. That originally was a silicon 28 plant. It's not really big enough to produce the kind of commercial quantities that we have customers interested in us producing. For quantum computing, people are going to need silicon 28 enriched to a level of 99.995%. That's an extraordinarily high level of enrichment. And we believe we have a plant that can produce that during 2023. We'll expect to start discussing this with customers in the next sort of several months or so. This is a major this could be a major opportunity longer term. If quantum computing becomes a success, the world's going to need significant amounts of silicon-28 to process these processes. Also, it's believed that silicon-28 enriched to a lower level is also able to enhance solar panels and make solar panels more effective. And so we expect to start supplying some research companies into that as well. People ask us about uranium and nuclear fuels. So we're not enriching uranium right now. We don't have any of the permits required to do that. We believe we might be able to enrich uranium at some point in the future. Our technology might be able to be modified to enrich uranium. Uranium is becoming interesting because it's becoming increasingly clear that to meet 2025 carbon emission goals, the world's going to require more nuclear power. Wind and solar are simply not sufficient or reliable enough to provide a base load of fuel to a population. Russia's responsible for about 40% of the global uranium enrichment. The United States currently imports about over 90% of its uranium requirements, and there's a lot of discussion in Congress about trying to increase the amount of enrichment the United States does itself. And as you'll see on the right-hand side, there's a number of governments who are trying to get more nuclear power into their grid. You'll see there's some of the examples of governments trying to do that. The future of nuclear power, in our opinion, is likely the SMR, the small modular reactor. These small reactors are capable of powering, a city almost anywhere in the world at sort of 3.5 to 4 cents per kilowatt hour. So it gives really cheap energy to remote cities or cities that currently don't benefit from cheap gas or hydro or other sources of energy. The problem for these reactors is they require many of them require a special type of uranium. A typical nuclear reactor today requires uranium enriched up to 5%. Looking at SMRs, they're going to require uranium enriched up to sort of 19.75%. It's called HALEU, high affinity, low enriched uranium. We believe we can modify our technology to do this. And so we're currently in discussions with companies and other governments and regulators about whether or not we're able to start doing some research into this. This isn't the kind of project we're likely to do by ourselves. This is like a project we're likely to engage a partner in. This is a much bigger kind of size plant that we kind of feel that we really need a partner to be involved here. And then here's some of the other isotopes where, as I mentioned earlier, we have a lot of interest in. So zinc-68, we've had interest from customers for kilogram quantities of zinc-68. It's currently growing as a use in a diagnostic where they're converted to gallium-68. Also, there's a lot of clinical trials operating right now for copper-67, and that's produced using zinc-68. Chlorine-37 is likely going to be required for molten salt reactors. This is a type of new nuclear reactor that many companies are trying to develop. TerraPower is likely the leader in this. If these become a reality, these companies are going to require metric tons of chlorine-37 starting, second half of this decade. There really isn't a producer of chlorine-37 in the Western world today. Ytterbium-176 is available in gram quantities today. We believe we can produce it in kilogram quantities in a few years' time, and we're working on that at the moment. And lithium-6, again, lithium-6 is going to be required to enable nuclear fusion. We believe our technology might be capable of enriching lithium-6 too. So, the two dimensions to our company, as I mentioned earlier. Our focus for the next several years is on smaller plants that can enrich kilogram quantities of extremely valuable isotopes for very specialist purposes. Things like molybdenum-100, carbon-14, silicon-28. These are the kind of plants we can build ourselves. Things like zinc-68 as well. Typical cost to build one of these plants is $10 to $15 million. Takes about a year. Cash-on-cash payback is 2.5 to 3 years. They're the kind of plants we can fund ourselves, we believe. Bigger plants for things like HALEU, lithium-6, chlorine-37 would expect to require a partner for most of those plants. Often also the regulatory landscape for those plants is very different to the regulatory landscape for silicon-28 and so forth. So some concluding remarks. ASPI is a proven technology. We have our first plant operational. It started working a few weeks ago. It'll go into commercial production in the second half of the year. There are very favorable long-term market trends that should drive long-term secular industry growth. Many kind of emerging technologies have kind of acquired new isotopes that aren't currently really available today. As I said, our first isotope plant is operational. Construction on the second plant should finish in the second half of the year. Both these plants should enter commercial production during the second half of the year, and that should generate substantial amounts of free cash flow for the company. And we have a large backlog of interest driven by potential customers for many other types of isotopes. So I guess I'll stop there and take any questions.
Great job. Okay, we do have some questions for you, Paul. So Chad McLaughlin says, did you release guidance for your sales this year?
No, we've not released guidance for sales this year. We expect to start bringing in revenues towards the end of the year. And so obviously our revenues from the full year basis will depend exactly on what month they start to come in. So we've not given guidance for revenues this year.
And Kelly Delgado asks, what are the primary attributes for your technology?
So typical centrifuges, they spin around very fast and create kind of a vortex inside the tube. And the heavier isotopes move to the outside and the lighter ones move to the inside. And these are really good facilities for enriching heavy isotopes like uranium. And 6 countries have the ability to enrich these heavy isotopes today. Our technology is slightly different in that we spin the gas inside a stationary tube. So there's no moving parts in our plant except for the compressor that compresses the gas. It means that we're able to enrich light isotopes as well as heavy isotopes. So things like silicon-28, carbon-14, chlorine-37. To enrich those in a traditional centrifuge, you've got to bulk those up with larger atoms to make heavy molecules. We actually prefer lighter molecules. And so it's pretty unique in that we can do that very, very easily. In addition, our plants are much smaller than a traditional centrifuge. And I said there's no moving parts, so that they can go in. The foundation is much less significant where you put them. They're cheaper to build, and it's unlikely anyone's going to build a large centrifuge for producing kilogram quantities of an isotope. Whereas they're kind of small volume, high value isotopes is perfect for our technology.
So Tom G has a few questions. Answer them as you see fit. One, who are your customers? Also, who is your competition? And what are the advantages to a customer going with you over a competitor?
Right. So let me try and remember those questions. So who are our customers? So we've signed one contract with a large government buyer essentially a government buyer for kilogram quantities of molybdenum 100, and we announced that back in November. We're talking to a number of other radiopharmaceutical producers as well who require isotopes for the production of their radiopharmaceuticals. Also talking to semiconductor companies and governments for silicon-28, and then we're talking to a single large-scale nuclear consultant in North America for carbon-14. That's a fairly unique one. I guess, why do customers come to us? Why would they come to us rather than competitors? And who are our competitors? Well, typically, most stable isotopes in the world have been produced by government entities. So Rosatom, which is the Russian Atomic Energy kind of agency, they're the largest supplier of isotopes. Urenco, which is a British government, Netherlands, German kind of government-owned company, has never produced for stable isotopes. And then there's a French government-owned entity can produce isotopes too, and so can China. But there hasn't been much innovation in this industry for years. Why would customers come to us rather than other suppliers? First of all, we believe we'll be a very capable, reliable supplier of isotopes. Historically, with Russia being one of the main suppliers, supplies of isotopes have been fairly hit and miss. Some months are there, some months are not there, and that frustrates customers. So we hear a lot of customers wanting to take or pay type agreements where they can guarantee large quantities of volumes. And also, we've got a very low cost of goods for certain lightweight isotopes, and so we think we can price them pretty competitively as well.
All right. Well, thank you for that answer. Ben Stern wants to know why the stock price is where it is.
I get asked that question quite a lot, actually. Simple answer, I don't know why the share price trades where it is. I guess we're a new company. We only IPO'd in November. Not many people know about us yet. We're only really starting to do investor outreach and investor relations work kind of really about now. But we're starting to put out press releases. We're starting to put out milestones and meet milestones. And so I assume, I hope as we hit home on more milestones and we develop more customers and more clear bridge to revenues in the back half of this year and next year, I'd expect the stock price to reflect that.
Nathan Shaw.
Our goal for starting the company is to generate revenues as quickly as possible and generate as much revenues as soon as possible. Again, I think if we start to do that, that will help the share price.
Understandable. So Nathan Shaw wants you to hash it out a little bit more. So which isotopes are you going to be producing for sale towards the end of the year? And he asks, for what purpose? Why are people buying them?
Okay, so carbon-14 is used as a tracer during the development of pharmaceuticals and agrochemicals. And you lace a product with carbon-14 to see how it flows through the environment and the ecosystem. It's a pretty small market. It's, maybe 200 grams a year. It's not actually even measured in grams. It's measured in curies, which is a measure of radioactive activity. We'd expect to be selling carbon-14 by the end of the year, and that will be bringing in substantial revenues. We have a contract to sell molybdenum-100, so we expect to be selling that as well towards the end of the year. And that's used in the healthcare industry to convert into either moly-99 or technetium-99. And then we're in discussions with many potential customers for silicon-28, but we haven't signed any contracts yet. We're still discussing those at the moment.
All right. Thank you for that. Ruben says, lithium, zinc, nickel, carbon, are these your main focus? And which will you be selling first?
So as I mentioned a moment ago, carbon-14 is likely to be our first isotope we sell. It could be molybdenum-100, it could be silicon-28. All three will be coming on around about the same time. So exactly which one comes first is difficult to predict. They should all be coming through towards the second half of the year. And in terms of the pipeline of opportunities we have, we're in discussions with a number of potential customers for those. And I can't really predict on the timing of those. It's likely future plants we build will not be in South Africa. Our first two plants are in South Africa. It's likely our future plants will be in another country, preferably one that benefits from low-cost renewable energy.
Wonderful. Glenn says, you mentioned solar and quantum computing. So with the proposed and executed bills by the government and the new chip factor initiative, are you eligible for any grants?
Difficult question. I think it depends if we build plants in the USA or not. We talk to a lot of government entities in the US and other countries as well. So we may be eligible for grants, but let's have to wait and see. I would say there's a lot of grants in nuclear power, a lot of focus on nuclear power now as well. So the DOE's, put about sort of $4.5 billion into the SMR programs over the last several years and over the next few years. And there's about $700 million labeled for production of HALEU, domestic production of HALEU, in the Inflation Recovery Act, the Inflation Act.
So Tom Jennings says you're taking on some big projects. Therefore, are you in talks with any majors who can help with funding or infrastructure to help you fulfill these projects?
Yes, we are. I mean, a lot of customers, who I think are going to want isotopes over the next several years. Most of our discussions, they made it very clear, don't worry about the funding and the money for these plants. If you need capital, we have capital to do it. If you can do this, we can help fund it if needed. So we'll have to see how those discussions go over the next several months and years. But our focus initially, the company was to get our first two plants up and running with the cash that we had. We've raised $20 million in total since we incorporated the company about 18 months ago, and that $20 million is basically enough to get our first two plants to the point where they can start producing commercial product.
Nate Silva wants you to talk about your balance sheet and asks, are you sufficiently funded to get you to sales? And will the sales cover your burn?
So, again, we haven't really given any financial guidance because we're such a young company. But I think, we raised another $5 million just last week. And, we're a pretty prudent and frugal company in terms of how much we spend. You can look at our 10Q from last December on S1 to see how much we spend. And we don't have a lot of expenses. Most of our employees are in South Africa where labor is fairly inexpensive and leases are fairly inexpensive. So we've got a pretty low cash burn. I'd like to think that we start generating significant revenues that can cover that cash burn, fairly soon.
And Brendan Phillips wants you to talk a little bit more about your team. Talk about their experience or some past deals that they've been involved with.
So in terms of our management team, we bought these two half-built plants out of bankruptcy, basically in South Africa. So we found them about 3 years ago, and our two lead scientists there are both nuclear physicists. Both have got PhDs in physics and chemistry, and they were part of South Africa's nuclear program back in the 1980s and 90s. And then in 1994, there was a change in regime in South Africa, and South Africa exited nuclear enrichment. And so our scientists were kind of left looking for work, and they started to focus their attention on enrichment of stable isotopes for friendly needs such as medicine and advanced semiconductors. So there are two main scientists in South Africa. In terms of our board members, we've got a pretty diverse board. I've spent 20 years on Wall Street where I've met most of the board, where I kind of got to meet most of our board. Our vice chairman is Sergei Vasetnov. He's had a 20-year career on Wall Street and was a very senior employee at LyondellBasell for 5 or 6 years in the 2010 to 2016 timeframe. So we've got a mixture of experiences of finance, chemical engineering, chemical processing, catalysis, as well as nuclear physics. So it's a pretty diverse team we have.
Thank you for that answer. Jordan Phelps asks, besides green and technology, are there any military applications for your carbon or other products?
Yeah, there may be, and we've spoken to a couple of government entities about possibility for research of certain isotopes for government entities. We'll have to see where those discussions go over the next several years.
And then we've got 3 questions from Al. What will be the size of your orders?
Most of our orders are in the gram or kilogram type quantities. But when these products are sold at hundreds to tens of thousands of dollars a gram, a few grams can actually be extremely valuable. But again, these shipping our product is not shipping costs are not a large part of our cost of goods, and so that will allow us to put plants in locations where we can benefit from cheap energy.
And do you have sufficient funding or a credit line to fulfill them?
Again, we raised $5 million last week in a private placement, and again, we haven't really given guidance, but I have said that we think we'll bring in revenues towards the second half of the year, and I've said that we have a very low frugal cost base, cash burn.
And last question from Al, what will the margins be? Do you have any projections on that?
Yeah, again, it depends on which isotope we sell and what kind of quantity, but most of our isotopes think about pharmaceutical-like margins, so 80 to 90%, that kind of level. So there's 20 years of research and development has gone into this process, and so this is a high-tech business. Again, it also depends upon exactly which isotope. Some isotopes are cheaper to produce than others, depending on what level of enrichment they go to, whether they want a metal or an oxide or a gas. And so it just depends exactly what customer wants. But think about kind of 80% as being probably like an average kind of gross margin for the long-term mix of this business.
Wonderful. Well, Paul, our time is up. Do you have any closing remarks for the viewers?
Thanks so much for your interest. And if you've got any questions, feel free to reach out to us. You'll find our slide deck on our website, and there you'll be able to contact us, and happy to receive any questions and interest from people. Thank you very much.
Wonderful. Thank you so much. Come back again with some updates. Okay, everyone, stay with us.
Bye.
We'll be right back with our next presenter.